Hello, welcome everyone. In this video, I'm going to work out a couple of examples of a square root function. In this particular case, our square root variable is in the denominator. So we're going to use the power rule of derivatives to figure out the derivatives for these two examples that I have on this in this video. So let's go ahead and start with this is our power rule right here. So I'll go ahead and do that. If you have an nth degree polynomial, basically the derivative of this is going to be this n times x raised to the n minus 1. So that's how we take the derivative of a polynomial. And in this case, I'm only using a monomial, which means there's only one term for this particular function, or the next one in the next example. So let's take a look at it. Before we take this, we start with the derivative. Let's take a look at the domain of this function. So we have a square root of x. So we have a couple of restrictions here. First, x cannot be negative. So x cannot be equal to a negative number. Okay, negative number. Okay. And on top of that, x cannot be 0. Cannot be 0. Because if we have x equals 0, what happens is 1 over square root of 0 is 1 over 0. So this is undefined and the derivative won't exist. So we're looking at the domain where x is greater than 0. It cannot be equal to 0. So this is going to be the domain of our function. Okay. Domain. All right. So now we know this. Let's go ahead and start working out the problem. So this is 1 over square root of x. So what I'm going to do, I'm going to remove the radical sign and I'm going to put the exponent that is associated with that radical form, which is 1/2. So basically we have 1 over x raised to the 1/2 power. And now we want to take the derivative of this particular function. So we have d over dx of 1 over x to the 1/2 power. Okay. So we can use the law of exponents here. If we have something in the denominator, we can move it in the numerator and change the sign of the exponent. So that's what I'm going to do next. So d over dx, and instead of 1 over x to the 1/2, I'm going to put it as, I'm going to bring this in the numerator and change the sign of the exponent. So it's x to the negative 1/2. And now we can go ahead and apply this power rule. So we have this negative 1/2, which is the exponent, becomes the coefficient or the multiplier in front. And then we have x to negative 1/2, and we subtract 1 from it. And I'm just going to go ahead and simplify it further. So negative 1/2. And when we simplify this right here, negative 1/2 minus 1, you get x to negative 3/2. And the next thing I'm going to do, I'm going to take it into denominator, again using the law of exponent. So we have negative 1 over 2, and then this becomes x to the negative 3/2. I'm going to take this in the denominator, so it becomes x to the 3/2. That's just a little manipulation, and that's it. And then we go ahead and simplify it further. So 2 times x to the 3/2, because 2 is also in the denominator and they both are multiplying. So and to simplify it further, you can write it as 1 over 2, and it's the x to the 3rd power, and that's raised to 1/2. And then we can further simplify it this is just a little manipulation using the laws of exponents. So we have 1 over 2, we have square root of x cubed. That would be our final answer. And all these formats, and there is a negative here, so I forgot about that. There's a negative sign in front, so don't forget that. So all these are correct answers depending on, whichever you want to use. They all are correct, or what is expected from you. All right, let's go to the next one. Do this. Here we have another function, square root function where our square root term is in the denominator. So I'm gonna use the little, same thing as we did before. Let's simplify this. So d over dx, and I'm gonna simplify this as it's x to the 5, and then a cube root, I'm gonna write it as to the 1/3. Okay, so I simplified this into this. So in the next step, what I'm gonna do, I'm gonna simplify it further. So 1 over, and when we have exponents, we can multiply them. Okay, so x to the 5 raised to the 1/3 is basically x to the 5 times 1/3. This is the laws of the exponent property. The next step I'm gonna do is d over dx of 1 over x to the 5/3. When we multiply 5 times 1/3 is 5 times 1 is 5 over 3. So now we have this form right here, and then we can go ahead and take it to the numerator, d over dx. So we can take it to the numerator and write it as x to the negative 5 over 3. And then we take the derivative then. Okay, so negative 5/3 becomes the coefficient or the multiplier of the function, and then we have x to the negative 5/3 minus 1. We subtract 1 from it to when we take the derivative, and then we have negative 5 over 3. And when you solve this, negative 5 over 3 minus 1, it becomes negative 8 over 3. That's when we simplify this exponent, when we subtract negative 1 from negative 5/3. And the next step is negative 5 over 3. I'm going to take this into the denominator. So it becomes 1 over x to the 8 over 3. And in the next step, I'm going to simplify it further. So negative 5 over 3 times 1 over, so it becomes x to the 8 raised to the 3rd. We can, expand it into this form, change the 8/3 as a 8 times 1/3. So in the next step, you can write it as negative 5 over 3, and you can put a cube root and x to the 8. Okay, so this would be the final solution for this problem when we take the derivative of this function right here. Okay, all right, that would be it. That would be the end of this video.